So in this video, I'm going to briefly talk about inverse trigonometric functions, and the whole point of this is so that you have a better understanding of the important features of inverse trigonometric functions, specifically the domain and the range of these functions. So what I'm going to start off with is talking about just the original function, sine, cosine, secant, cosecant, tangent, cotangent. So with sine, and I'm just going to treat these as the normal trigonometric uh, intervals. So from pi over 2, pi, 3 pi over 2, 2 pi. And I'm going to do the same thing on the other side. But you can just treat all of these the same way. And I'm also going to put this as 1 and this as -1, just so that they're all consistent. Important thing to remember about sine is it always starts at the origin. They all have the same wave-like pattern. So they go up, then back down, then back up, and they repeat on both sides. Okay, so the sine function should look a little something like this, and I know my drawing's not completely perfect. Okay, um, so if you notice, its range is always from -1 to 1. Now, the thing is if I just talk about the sine function in general, we would say that its domain is all real numbers because really and truly I can plug in any number I want. The problem is that my goal is to try to make it an inverse. My goal is to try to make it so that it is a one-to-one function and therefore can be inverted. Well, if you look at this graph, you can pretty plainly see it's not going to pass the horizontal line test, like ever, unless I restrict this function some way, somehow, so that it is. And in this case, what we do is I try to find a way to make it go from -1 to 1 without ever repeating. And the best way to do this is if I start here at -pi/2 and I just follow it all the way up until it hits its maximum at pi/2. And that is going to be one full iteration of all the way from -1 to 1, one full iteration of the sine function. So I'm going to restrict the domain of sine to -pi/2 to pi/2. Now, arc sine or inverse sine is going to switch that. Remember, inverses, you switch the x's and the y's. They are reflections over the line y equals x. So essentially, all I do is if I know the domain and range of the original function, I can switch them, and that's the domain and range of my new function. Okay, so there you have it. So that's arc sine's domain and range. The domain is from -1 to 1, so I can plug in any number between -1 and 1, and the range will be -pi/2 to +pi/2. Now, I'm going to move on to cosine. Now, cosine's a little bit different. It starts at 1 and goes down from there, and it goes back up. And it repeats, does the same thing on both sides. So it has this, again, nice little wave-like pattern, okay? And again, my drawing is not perfect, but it looks pretty good. So the range again is from -1 to 1. That's true of both sine and cosine. And in this case, again, the domain, if I think about the entire function, is positive infinity to negative infinity, but I'm trying to invert this. I'm trying to restrict this domain so that it is 1 to 1. Well, so in this case, instead of starting at the bottom and going to the top, I'm going to start at the top here at 0, and I'm going to follow the roller coaster all the way down to where it hits its minimum, to where it hits its trough. So peak to trough, that starts at 0 and it goes to pi. Okay, so that means again, if I want to find arc cosine or the inverse of cosine, we just switch them. So the range is going to be from 0 to pi, and its domain is -1 to 1. All right, so that handles those two functions. Now, if you notice, when I come down here and I did tangent and cotangent, I kind of have these switched from what most people think is normal. And there's a reason for that. Cotangent, if you recall, is cosine over sine. So that means that wherever sine function, the function that's right above it, hits the x-axis, I'm going to have an asymptote. And the same kind of idea happens with tangent, is that it's sine over cosine. So wherever cosine hits the x-axis, I'm going to have an asymptote. So that's an important fact to think about here. And let me kind of just sketch in those asymptotes. I think I'll do it in this yellowy color. So that means cotangent's actually going to have an asymptote here. It's going to have another one at pi. It's going to have another one at 2 pi. Okay. So I'm just sketching in these vertical asymptotes. Okay. Cosine's a little bit different. Again, it's whenever tangent's going to be whenever cosine hits 0, hits the x-axis. Okay. Oop, I went over a little too far on that one. An important thing to know about tangent and cotangent is they always have what I would consider, it kind of looks a bit like a cubic function. It's not exactly a cubic function, but it is very similar. The other thing that I always look at is where is it positive versus negative. If you notice over here, right after 0, both sine and cosine are positive, which means that I should be positive on this side, so it's going up this way. And over here on the left side of 0, cosine is positive, but sine is negative. So I should have a negative sloping down on that side, okay? And again, it just kind of repeats itself. It does the same thing over and over and over again, okay? All right, let me draw these in. Now, cotangent's going to have a very similar idea. Whoops, I didn't mean to hit that button. Let's see. Again, if I look over here right away, right after 0, this side is going to be positive. But if I go past pi over 2, cosine ends up being negative while sine is positive. So it starts having a negative side down here. So again, both of these kind of look like cubic functions. Just one goes up from left to right. The other one goes down from left to right. Okay, there we go. And there's that function. Now, hopefully you're picking up on both tangent and cotangent. I'm going to scroll down just a little bit. Both tangent and cotangent have vertical asymptotes, a lot of different places. That means their inverses, arc, cotangent, are going to have a lot of horizontal asymptotes, or in this case, I'm going to restrict it down to just 2. So let's see. In this case, we have a range from negative infinity to positive infinity. So I'm going to write that in there. I'll do that. Let's go back to that green color. Okay, there's green. So from negative infinity to positive infinity for those ranges. And when I try to do the single iteration, the one where it covers negative infinity to positive infinity, I'm going to kind of follow that same pattern I had before, but notice the only thing different in this case is I have vertical asymptotes, so I can't use brackets like I did with sine and cosine up here. I'm going to have to use parentheses. So if I look at tangent, this is negative pi over 2 where one asymptote is, and positive pi over 2 where the other is. So I'm going to choose a domain from negative pi over 2 to positive pi over 2 with parentheses. That means, again, when I do arc tangent, when I do the inverse, they're going to switch. So the domain is negative infinity to positive infinity, and its range is from negative pi over 2 to positive pi over 2. For cotangent, again, if I'm looking for one full iteration, I'm going to start here at 0, and I'm going to go to pi. Again, vertical asymptotes, so you please, please, please use parentheses, not brackets here. So from 0 to pi. All right, so again, when you go to do the inverses, they switch. So domain is from negative infinity to positive infinity, and our range is from 0 to pi. Now, very similarly, again, I have these in a specific order. If you recall, I'm going to scroll down again in case you missed this. So sine goes with cosecant. It's the reciprocal function. And secant is 1 over cosine. So they're going to have those same kind of asymptotes, vertical asymptotes like I had before. So let me draw those in there again. All right, there's one vertical asymptote. Then we should have another one here, 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 and here. Special things about secant and cosecant, instead of looking like cubic functions, this has almost parabolic, it almost looks like parabolas, but they alternate. One goes up, one goes down, one goes up, whoop, one goes down, one goes up, one goes down. So I just need to check, and let me come back up here to what cosine looks like. If I look up here at cosine, it's positive up here in this first section. So secant will also be positive up here in this first section. And let me go over here. Sine is positive in this first section, so cosecant will also be positive in this first section. And again, like I said, they just alternate. Okay, so they go like this. Up, down, up, down, up, down. And again, they look like parabolas. They're not exactly parabolas, but they're pretty close. Um, just don't call them parabolas because they're not actually parabolas. Um, so important thing to notice about both secant and cosecant when I go to try to write the domain and the range is, again, they have vertical asymptotes, so I'd expect arc secant and arc cosecant to have horizontal asymptotes. Um, excuse me. So cosecant has a domain, and if I make sure I'm very careful to have one iteration, it's actually going to start here at negative pi over 2 and go down, and it's going to have pi over 2 and up. So let me write that down again. So negative pi over 2 and pi over 2. So notice again, I have to skip 0 though, so be careful here how you write this domain. So cosecant's from negative pi over 2 to the vertical asymptote of 0, and from 0 to pi over 2, that's the other vertical asymptote, or the other half, excuse me. And the range, be careful again writing the range. So this is going to go from negative infinity to negative 1. It does hit negative 1, so I'm going to put a bracket, and then it picks up at 1 and goes to infinity. Secant's going to be very similar, although again, be very careful here. It's going to start at 0 and go up, and the other side is going to go from pi down. So my domain here will be, uh, excuse me, I meant to put brackets around some of these numbers. So let me see, that was negative pi over 2 should have been a bracket. My apologies. And pi over 2 should be a bracket because it actually hits those points. My apologies. So it's just parentheses around the 0. So let me go back. Sorry, domain. We're going to start at 0 and we're going to go to pi over 2 where our vertical asymptote is. Hit a bracket or hit a parentheses pi over 2 to pi with a bracket. Notice it's kind of following along. Secant, tangent, and cosine all kind of have the same ish domain. 0 to pi, 0 to pi, 0 to pi. Um, and the only thing that's really big difference is the ranges from each of these. So negative 1, 1 to infinity. Again, they switch. They do something different when you talk about their inverses. So when I do the domain, it's going to go from negative infinity to negative 1 and from 1 to infinity. And then when I do the range, it's going to go from negative pi over 2 to 0, parenthesis, 0, parenthesis, pi over 2, bracket. And again, same thing over here. Domain is going to be negative infinity to negative 1, and from 1 to infinity. Range is going to be 0 to pi over 2, and pi over 2, I forgot my u, to pi. Hopefully this again helps you kind of better understand all of this important information because as I go through and do this in the next stage, when I talk about calculus with inverse trig functions, we're going to have to be very careful of what numbers we can and can't plug in here. So please make sure you have all of these domains and ranges written down correctly. And I'll see you